Hello, this is Ms. DB. In this video, we will go over how to do surface area of pyramids and cones from Chapter 10, Section 5. So there's some variables that we need to know what they are. L stands for lateral area. Capital P stands for the perimeter of the base. And perimeter is just you add up all sides. So that depends on what the base shape is. For a pyramid, you need to know what the base shape is. It's a regular pyramid, meaning that the base will be a square, which has all sides congruent, or an equilateral triangle, or a hexagon, a regular hexagon, or regular pentagon, or so on. The little L, that's a cursive L, that stands for slant height. The slant height measures, if you looked at just this triangle that makes up one side of your pyramid, the slant height is the height of that triangle. So this is L. They don't always give you L. Sometimes you have to use Pythagorean Theorem to find it. In surface area, it's the same thing, 1/2 perimeter times slant height, but then you add the area of the base. Big B is area of the base. So whatever the base shape is, you have to find the area using the formulas that we learned in Chapter 9. It's never just a number. You have to calculate that. I'm not sure why that did that. For cone, it's just a simple formula for lateral. Pi times r times L. L, again, is slant height. Radius is r is the radius of the base. Capital L is lateral area. The surface area, you can use this formula here. Pi times r times L, that's the lateral part, plus the area of every circle is pi r squared. So you add those two parts together and you'll have the total surface area. These first questions are just asking you to write the formulas, making sure that you understand what all those capital letters and lowercase letters are. So remember that sometimes we have to find the slant height. In this first one, number 5, no slant height is given. So the formula to find the, let's see, we need lateral and surface area of the pyramid. The base is a square. The height of the pyramid is 15, but there's nothing in here that asks you to use the height of the pyramid. That's not part of the formula. We have to use what they give us to find what we need in the formula, which is slant height. So I drew a little right triangle in here so that you could picture there's a triangle that this is the height of the triangle, and then picture this being sketched outward, and then here's this would be the height of this triangle here. So what is if we are trying to find this amount, that's the slant height, we know that 15 is the height of that triangle, and the base of that triangle, little b, would be half of 16, because the whole side would be 16. We're going from the center out, so that would be 8. So the first thing to do in this one is use the Pythagorean Theorem. 8 squared, a squared plus b squared equals c squared, and the hypotenuse is the slant height that we're looking for. So this is an L here. 8 squared plus 15 squared equals L squared. So you use that to find the slant height, and then you can go back and use the formulas after that. Remember, you're going to be finding big P is the perimeter, will be 16 plus 16 plus 16 plus 16. The area of the base is a square, so area of a square is side squared, so 16 squared would be the area of the base, whatever that equals, 256, I believe. And the perimeter would be 16 plus 16 plus 16 plus 16, or 16 times 4. And you'll have to find the slant height before you can finish this up. Now in number 6, the slant height is given to us as 5. So we know that the height, or the slant height, L, is 5. The base of this triangular pyramid, this is a regular, notice that they all say regular, So that means if one side of the base is 8, then the other two sides are also 8. So the perimeter is 8 plus 8 plus 8, or 8 times 3 is 24. Now what about the base? The base is a triangle, and we find the base by going 1/2 base times height. But what is the base of this triangle? So let's, oh, the base is 8. We can do that. That's fine. What is the height, though? We don't, the height is not given to us yet, so we can't find the area of it. However, we do know that all these sides are also 8. So we can use Pythagorean theorem again to find the height of this triangle, because let's see, that would be half of that is 4. This would be 8, and this will give us the height of our triangle. So in this one, we would do a squared plus b squared equals c squared. The c, that is the hypotenuse, is 8 in this one. So 4 squared plus h squared equals 8 squared. So 16 plus h squared equals 64. Subtract 16 from both sides, and we get 48. So h squared is equal to 48. And then we take the square root of both sides. So h is equal to the square. You can either get the exact value by simplifying this. That would be 4 square root of 3. Or you can get the decimal approximation for these. Square root of 48 is 6.928. I'll say 6.93. 6.93 approximately. Okay, do we have everything we need? Now we need the area of the base. Okay, the area of the base would be 1/2. We know the base of the triangle, little b, is 8. Now we know the height is 6.93. So that will give us the area of the base. So for lateral area, let's look at the formula again. Lateral area of a pyramid is equal to 1/2 perimeter times the slant height. That one you can find without any calculations, or well, not much calculations. 1/2 the perimeter times the slant height. We know the slant height is 5. We know the perimeter is 24, so you can find that one quickly. To find the surface area, that's equal to the lateral area, which you'll find right there, plus the area of the base, which we have right here. I don't have the whole thing calculated, but it is going to be whatever this is. 1/2 times 8 times 6.93 will give you the area of big B, the area of the base of the triangle. All right, let's look at some cones. In number 7, we do know the slant height. The slant height is 5. So the formula is that the lateral area is just pi times the radius, which is 4, times the slant height, which is 5. The surface area is equal to that. Whoops. It's equal to the lateral area plus the area of the base, and the base is pi r squared. And you know that r is 4, so that will be pretty straightforward. In number 8, we do not yet know the slant height, so we're going to have to use the Pythagorean theorem to find it. So we have a right triangle. We know one side is 10. We know another side is 24, and we know we're looking for the hypotenuse, or the slant height, which is L. So 10 squared plus 24 squared equals L squared. And then you can use the same formulas. In number 9, there's no picture, but they do tell us that R is 3 and that the slant height is 12. You can draw a picture if you want. The radius is 3 and the slant height is 12. We don't need the height of the cone, so that'll be enough information to find the lateral and surface area. All right, the next section, if you remember this and learn this, you don't actually have to find the surface area. You just need this rule. If the dimensions are doubled, then the surface area is multiplied by 2 squared, or 4. This is the same as the surface area of prisms and cylinders that you learned in section 4. The rule is that the surface area and the lateral surface area, if they ask you for it, will have the same effect squared. So if it's double, that's times 2. The surface area will be times 2 squared, or times 4. So you don't actually have to find the surface area, you just have to say how they would change. And what you would write for this, I'm going to type this, like for number 10, you would say the surface area will be multiplied by, then you find the dimension. So in number 10 it was 1/5. 1/5 squared, which is the same as 1/25. In 11, you will write the exact same thing. You can copy and paste this. It'll be multiplied by, and then you take this amount and you square it, and then you simplify that. When you square a fraction, it means you square the numerator and you square the denominator. So you're going to take 3 squared over 2 squared and then simplify and say what that is. Now in the last couple of problems, you're going to find the surface area of a composite figure. In number 12, you're going to find the surface area of the prism using the methods that we used in 10.4, but you only need one base because the top one is covered up by the pyramid. And then you find the area of the pyramid, surface area, but you only need the lateral because the base is overlapped, hiding with the base of the prism. So you'll need the lateral area of the pyramid plus, let's say, the lateral area of the prism plus the base, just one base of prism. So you don't need to add both areas because this one is not on the outside surface. We only count the outside when we count surface area. Number 13, you will need the lateral area of the cone, not the base, because the base is is covered up because it's overlapping with this prism. You need the lateral area of the prism plus that square prism there, plus one base, that square, and then you have these little corner pieces. So to find those little corner pieces, you would take the area of the base of that square, 4 times 4, 16, and then you subtract the area of the circle. So this would be equal to, I'm going to put this in parentheses, area of square base, which is 16, minus area of circle base, which would be, let's see, the radius would be 2, so it would be pi r squared. That's a circle. So you'd take 16 minus pi r squared would be 4. So 16 minus 4 pi. That would give you that little extra piece that you would have to add on for those little corner pieces. All right, so I've set up how to do most of those problems, or a lot of those problems. There's one more question at the end, and then there's a bonus. If you want to do the bonus, you can. The question at the end is saying that we have a water cooler, and there's these little cone-shaped paper cups, and he uncurls one, Muhammad uncurls one, and this is the result. We're not going to find the little glue tab part. What we want to do is find the diameter of the cone. So before it was unrolled, what was the diameter all the way across here. It's not 4, it's not 8, so you have to do it this way. There's an example problem like this on page 692. So it turns out that the lateral area of this cone, which is this piece of paper that would make up that cup, and it has a slant height of 4, would be equal to 1/4 of the area of the circle. You can kind of see how that's true. It's 1/4 of a circle that has a radius of 4. So this is the 1/4 of a area of a circle that has a radius of 4, and this is the lateral area of the cone. So you can use this to find r, and then you can double it to find the diameter. All right, so that's it. Have a great day. Make sure you let me know if you have any questions.